Your 2-6 lesson goes over solving inequalities. Your part 1, which is what we're doing today, focuses on linear inequalities. So these inequalities will not include an x to a power. It'll just be an x, okay? So your whole idea is to isolate your x value. Remember, when you're working with inequalities, this is something you should know from previous years, previous courses, that if you are multiplying each side of an inequality by a negative number or dividing each side of an inequality by a negative number, you need to flip the way that your inequality sign is open. That's if you're multiplying or dividing each side by a negative. So if that's the case, flip the inequality sign. With the way that these work, you're going to solve the inequality and then graph the inequality and then write the interval notation for the inequality. Remember, if your x is on the left side and it's by itself, the way that your inequality sign points is the way that you'll draw your line. Open circles for just less than or greater than, closed circles for less than or equal to, greater than or equal to. So keep this stuff in mind. It's all stuff from the very beginning of the year, but like I said, keep it in mind while you're working on this. For example, A, you have 5x minus 7 is greater than 3x plus 9. So our whole idea is to get the x by itself and on the left side. So I'm going to start this one by moving the 3x over, so I'm going to subtract it from both sides. This is going to give us 2x minus 7 is greater than 9. From here, move your 7 over, so add it to both sides. That's going to give us 2x is greater than 16. Then we divide each side by the 2. We're dividing by a positive, so you don't have to flip anything. And this is going to give you x is greater than 8. Now, if you were to graph this on a number line, you would find your 8. You would have an open circle because it's not also equal to. And since x is on the left side, your sign points to the right. Your line is going to run to the right, which means the interval notation for this smallest number to largest number, it's starting at the 8, then going to positive infinity. Your infinity automatically gets the parentheses on it. We have an open circle on the 8, so that 8 will also get the parentheses on it. For example, B, we have negative 7x plus 9 is less than or equal to 2x plus 4. So I'm going to work with my x's first. I'm going to move the 2x over by subtracting it from both sides. This is going to leave us with a negative 9x plus 9 is less than or equal to 4. From here, we move the 9 over by subtracting it from both sides. That gives us negative 9x is less than or equal to negative 5. From here, we want x by itself, so we need to move that 9 or that negative 9 away from it. So we're going to divide each side by that negative 9. Again, if you're multiplying or dividing each side of an inequality by a negative, you flip that inequality sign. So this becomes x is greater than or equal to positive 5/9. So on your number line, you find your 5/9. You're going to put a closed circle on this 5/9 because it is also equal to. Your x is on the left, your sign points to the right, your line is going to run to the right. So that means for your interval notation, your smallest number is the 5/9. That goes down first. It goes to positive infinity. That goes down second. Your infinity automatically gets the parentheses. Your 5/9 is going to get a bracket though, since there's a closed circle on that. If we look at some other examples, for number 1, we have 2x is greater than or equal to 8. For this one, we're just going to divide each side by the 2. And we have that x is greater than or equal to 4. So on our number line, we're going to find that 4. It's also equal to, so we're going to put a closed circle. And that line's going to run to the right. Since x is first, your sign points to the right. So that's going to give you 4 to infinity with your bracket on the 4. For number 2, you have 3x plus 11 is less than 5. So we're going to move the 11 over first. So we're going to subtract it from both sides. That gives us 3x is less than negative 6. Then we divide each side by the 3. And we have that x is less than negative 2. So on our number line, we're going to find that negative 2. You're going to put an open circle on that -2 since it's just less than. Your x comes first. Your sign points to the left. Your line's going to run to the left. So that means the smallest number that line's going to is -infinity, which gets the parentheses. And then it goes up to -2. Open circle. -2 gets the parentheses as well. For number 3, you have 1 is less than 5 minus 2x. For this one, you want to get the x by itself, so we're going to move the 5 over first, and we're going to subtract it from both sides since it's positive. So that's going to give us -4 is less than -2x. Again, you're still getting x by itself, so we're going to divide each side by that -2. We're dividing each side by a negative, so that inequality sign flips. -4 divided by -2 is +2. We flip our sign to be open to the 2. And then -2x divided by -2 is just x. This is not written to where x is first, and I don't like that, so I'm going to rewrite it. If x is on the left, 2 is on the right, my sign is open to 2, it's going to stay open to 2. So this just means you have x is less than 2. So on your number line, you find that 2. That 2 is going to get an open circle. X is on the left in your inequality. Your sign's going to go, or sorry, your sign's pointing to the left, so your line's going to run to the left, which means you're going to from -infinity up to 2, not including the 2. So the parentheses goes on the 2 and the -infinity. For number 4, you have 2 times 7x minus 3 is less than or equal to 12x plus 16. For this one, you can do it one of 2 ways. If you were to divide each side by that 2, the 12x divided by 2 is possible, so is the 16 divided by 2. So you could divide each side by the 2 first, or you can distribute the 2. I'm going to distribute the 2 just because, to me, that's what I find, or I think you would do. So I'm going to distribute the 2 into the 7x minus 3, and that's going to give us 14x minus 6 is less than or equal to 12x plus 16. We move our 12x over by subtracting it from both sides. This is going to give us 2x minus 6 is less than or equal to 16. From here, we add our 6 over, so that gives us 2x is less than or equal to 22. Lastly, we're going to divide each side by the 2, so we have that x is less than or equal to 11. So when you draw your number line, you're going to make that 11. It's equal to, so you're going to put a closed circle on that 11. When x is first, or on the left side, your sign points to the left. So our line's going to run to the left, which means we're going from -infinity up to 11, including the 11. Now the next ones that we're going to look at are a little different than the ones we've worked with already. The reason why is because these are compound inequalities. So you are going to separate them to work with 2 separate inequalities and then work those through all the way. So if we look at example 5, we have 5 is less than or equal to 3x minus 4, which is less than or equal to 14. For this one, we're going to have, like I said, 2 inequalities. So one that's the 5 is less than or equal to 3x minus 4, as well as the 3x minus 4 is less than or equal to 14. From here, I'm going to solve the one on the left first. I'm going to move my 4 over by adding it to both sides. That's going to give us 9 is less than or equal to 3x. Then we divide each side by the 3 to get x by itself. And that's going to give us 3 is less than or equal to x. Again, I don't like the way this is written because x doesn't come first. So I'm just going to rearrange my terms to where x is on the left, 3 is on the right. My sign is open to x, so I'm going to keep it open to x. So that's just x is greater than or equal to 3. For the inequality that I have on the right, I'm going to move my 4 over first, so I'm going to add it to both sides. This is going to give us 3x is less than or equal to 18. From here, we divide each side by the 3, and we have that x is less than or equal to 6. On our number line, we have a 3, we have a 6. That 3 is going to have a closed circle on it because it's also equal to. Our sign, when x is first, points to the right, so our line's going to run to the right. For the 6, it's going to have a closed circle on it. When x is first, our sign points to the left, so our line's going to run to the left. So you're going to look for where these two overlap, since they are overlapping one another. You're going to darken where they overlap, and then get rid of whatever's to the left and the right of that. So don't take that into consideration when you write your interval notation. So with your interval notation, where these two parts overlap, you're going from 3 to 6. No other numbers, because they don't overlap in any other part. The 3 has a closed circle, so you're going to put a bracket on that. The 6 has a closed circle, so a bracket goes on that. So you're just going to have from 3 to 6, including both the 3 and the 6. For number 6, you have -8 is less than or equal to 5x minus 4, which is less than or equal to 5. Again, we're going to separate this into two inequalities and work both of them out. So we're going to have one that's -8 is less than or equal to 5x minus 4. And then we're also going to have 5x minus 4 is less than or equal to 5. For the inequality I have on the left, I'm going to move my 4 over first and add it to both sides. That's going to give us -4 is less than or equal to 5x. From here, we're dividing each side by the 5. And we have that -4/5 is less than or equal to x. Again, I don't like when x doesn't come first, so I'm going to rewrite this. I have x on my left side, -4/5 on my right. Sign is open to x, so it's going to stay open to x. For our next one that we had on the right, we have 5x minus 4 is less than or equal to 5. I'm going to add my 4 over first, just like I did with the other one. However, this is going to give me 5x is less than or equal to 9. Then just divide each side by the 5, and you have that x is less than or equal to 9/5. So on our number line, we're going to have -4/5 on the left, since it's less than the 9/5 on the right. Your inequality with the -4/5 is also equal to, so we're going to put a closed circle on that. Our sign is pointing to the right when x is first, so our line's going to run to the right. For the inequality that involves the 9/5, again, closed circle on that since it's also equal to. However, this one has your sign that points to the left, so we're going to run our line to the left. These two lines overlap between the -4/5 and the positive 9/5. They include both the -4/5 and the 9/5 since they have closed circles. So our interval notation will just go from -4/5 to 9/5 with brackets on both. For number 7, you're given -3 is less than or equal to 3x plus 7, which is less than or equal to 1/2. Again, compound inequality, I'm going to separate this into two and work both of them out. So it's going to give us -3 is less than or equal to 3x plus 7, as well as 3x plus 7 is less than or equal to 1/2. If I work the inequality out on the left first, I'm going to move the 7 over by subtracting it from both sides, and that's going to give us -10 is less than or equal to 3x. From here, we're going to divide each side by the 3. So that's going to give us -10/3 is less than or equal to x. Again, I don't like when x doesn't come first, so I'm just going to rewrite it as x is greater than or equal to -10/3. For the inequality that I have on my right, I don't like working with a fraction, so I'm going to multiply everything by the least common denominator to get rid of those fractions. So my denominator is 2. I'm going to multiply everything by 2. The 2 times 3x is going to give me 6x. The 2 times the 7 is 21. Keep the less than or equal to. 2 times 1/2 is 1. So from here, we're going to move the 21 over and subtract it from both sides. This gives us 6x is less than or equal to -20. Then we're going to divide each side by the 6. And we have that x, what's wrong? Oh, it is supposed to be 14. I don't know why I did that. I don't know. Thank you. I'm multiplying the 3 by 7 instead of the 2. All right, so 14 is less than or equal to 1. Thank you. All right, so now we're going to move the 14 over by subtracting it from both sides. So that's 6x is less than or equal to negative 13. Then we divide each side by the 6. So we have x is less than or equal to negative 13 over 6. Now, if you look at these two fractions, try to find out what your common denominator is and write the equivalent fractions of them, of what you have, so that way you know which one's greater than or less than. So if we look here, this negative 10/3 is the same thing as negative 20 over 3. Or sorry, 20 over 6. So if you look at these two fractions on your number line, the lesser one goes on the left, which is the negative 20 over 6. The greater one is on the right, so the negative 13 over 6. Okay. If you want to give the two with the like denominators, you can, or you can give the negative 10/3. It doesn't matter. It's the same thing. Okay. So with your negative 10/3, you're going to have a closed circle on that. When x is first, your sign points to the right, so your line's going to run to the right. For the negative 13 over 6, again, closed circle since it's equal to. Sign points to the left when x is first, so line goes to the left. We darken where these two overlap. We get rid of anything to the right and the left of them. And then our interval notation comes from the part that overlaps. So that's going to be from negative 10/3 to negative 13/6 with closed circles on both, so brackets on both. For number 8, we have 4 is less than or equal to 3x minus 2, which is less than 13. Again, compound inequality, so I'm going to separate this into 2 and work both of them. We have 4 is less than or equal to 3x minus 2, as well as 3x minus 2 is less than 13. For the inequality that we have on the left, we're going to move our 2 over first by adding it to both sides. That gives us 6 is less than or equal to 3x. Then we divide each side by the 3, and we get that 2 is less than or equal to x. I don't like when x doesn't come first, so that's going to give me x and 2, x on the left, 2 on the right. Sign's open to x, stays open to x. For the inequality we have on the right, we're going to move the 2 over, adding it to both sides. So that gives us 3x is less than 15. Then we divide each side by the 3, and we have that x is less than 5. On our number line, our 2 is going to be on the left, 5 is going to be on the right. 2 is going to have a closed circle on it since it's also equal to. When x is first, our sign points to the right, so our line runs to the right. With our inequality that has the 5, it's going to be an open circle because it's just less than, not equal to. When x is first, our sign points to the left, so our line runs to the left. These two overlap between the 2 and the 5, so we'll darken in that area. Get rid of anything to the right and the left of that. When you write your interval notation, you're going from 2 to 5. 2 has a closed circle on it, so it gets a bracket. 5 has an open circle on it, so it gets the parentheses.